In the vast expanse of space, there are objects so luminous, so powerful, that they outshine entire galaxies. These enigmatic sources of energy are known as quasars. They are the brightest and most distant objects in the observable universe, beacons of light sent from the farthest reaches of time and space. Discovered in the 1960s, quasars have long fascinated astronomers and physicists alike. What are these glowing giants? How do they shine with such extraordinary brilliance? And perhaps most importantly, what do they tell us about the origins of the universe? To understand their significance, we must first look back to a time when the universe was young and the seeds of galaxies and stars were being sown. Quasars are not just distant objects. They are windows into the past, cosmic time machines that allow us to peer into the early universe, revealing its secrets one light year at a time. At their core, quasars are powered by the most extreme force in the universe, supermassive black holes. These black holes reside at the centers of distant galaxies, where they exert immense gravitational forces. As matter from surrounding gas and dust spirals inward toward these black holes, it forms a rapidly rotating accretion disk. The friction and heat generated in this swirling disk cause the material to glow, radiating energy in the form of light, X-rays, and other wavelengths. It is this energy that makes quasars so incredibly bright, outshining entire galaxies in the process. But these cosmic giants aren't just shining because of the accretion disks. They also emit powerful jets of energy, fired from the poles of the black hole at nearly the speed of light. These jets can stretch for millions of light years, piercing the surrounding space like cosmic arrows. Together, the black hole, the accretion disk, and the jets form a quasar, an object so luminous it can be seen across the vast distances of the universe. Now, here's where it gets truly fascinating. Quasars are time machines. The light we see from a quasar today is not the light that it emitted last year, or even last century. It is light that has traveled for billions of years across the fabric of space-time, carrying with it a snapshot of the early universe. When we observe a quasar, we are essentially looking back in time, to a time when the universe was in its infancy. The light we detect today left its quasar long before the first stars and galaxies formed, long before life as we know it began. This light is a direct link to a moment in time that is almost incomprehensibly distant, a time when the universe was just a fraction of its current age. By studying the light from these far-off quasars, we can peer into the heart of the early universe, observing the conditions that existed during one of the most exciting and crucial periods in cosmic history, the epoch of reionization, when the first stars began to form and the universe transitioned from darkness to light. To understand the importance of quasars as time machines, we need to take a journey back, all the way to the birth of the universe itself. When the Big Bang occurred, around 13.8 billion years ago, the universe was a hot, dense soup of particles. Over time, it began to cool and expand, allowing atoms to form. But for the first few hundred million years, the universe remained dark, a period we refer to as the cosmic dark ages. Then, something remarkable happened. The first stars began to form. These stars were the first sources of light in the universe, and their birth marked the end of the cosmic dark ages. But even more incredibly, their light began to ionize the surrounding hydrogen gas, turning it from neutral to ionized and creating the universe's first glow. This period is known as the epoch of reionization, and it marks the point when the universe transitioned from opaque to transparent, allowing light to travel freely across space. Quasars are key to unlocking the secrets of this era. Their light carries information about the early universe, about the density of gas, the formation of the first galaxies, and the conditions that allowed stars to ignite. By studying the spectra of quasar light, we can learn about the composition and state of the universe at this critical moment in its history. But not all quasars are the same. The farther we look, the younger the universe we observe. Quasars that are billions of light years away are actually showing us a much younger, more primitive universe than we can see with local galaxies. These distant quasars have been traveling through space for billions of years, and the light we observe today is a direct glimpse into the conditions of the cosmos when it was in its infancy. The most distant quasars we've discovered are located over 13 billion light years away, meaning their light began its journey just a few hundred million years after the Big Bang. These quasars are truly time machines, providing a direct link to the universe's formative years. Through these distant quasars, we can study how the first galaxies formed, how they evolved, and how they interacted with the surrounding cosmic gas. We can observe the universe as it was just a few hundred million years after the first stars ignited, a time that we could not otherwise study, except through the eyes of these ancient beacons of light. Quasars not only offer a glimpse into the early universe, but they also play a pivotal role in understanding cosmic growth. They help us investigate the formation and evolution of galaxies. We now know that supermassive black holes, which power quasars, are often located at the centers of galaxies, suggesting a deep connection between the growth of black holes and the formation of galaxies. In fact, the evolution of a quasar may parallel the evolution of its host galaxy. As the black hole grows and accretes more matter, it influences the galaxy around it, regulating star formation and shaping the very structure of the galaxy. Quasars give us insight not just into cosmic events, but into the cosmic dance between galaxies and black holes, a relationship that defines the growth of the universe itself. Through the study of these powerful objects, we can begin to piece together the history of galaxies, from their humble beginnings in the early universe to their current form. We can watch as the galaxies evolve, driven by the enormous energy of their central black holes, and learn how they interact with the surrounding cosmic gas, stars, and dark matter. As we look to the future, the study of quasars will continue to provide us with a deeper understanding of the universe. New telescopes and observatories, such as the James Webb Space Telescope and the YELT, Extremely Large Telescope, will allow us to peer even farther into the past, unlocking secrets that have remained hidden for billions of years. With each new discovery, we are getting closer to understanding the full story of our universe's evolution. From its chaotic birth in the Big Bang to the formation of stars, galaxies, and the supermassive black holes that continue to shape the cosmos today. Quasars will remain a key piece of the puzzle, helping us to answer the most profound questions of our existence. How did the universe evolve? How did galaxies form? What role did black holes play in shaping the cosmos? And perhaps most fundamentally, we will continue to look to quasars for a glimpse of the universe's beginning, a time long before we existed, but one that is forever written in the light of these distant, glowing time machines. Quasars are more than just distant lights in the sky. They are time capsules, preserving the history of the universe in their brilliant rays. Each one is a beacon from the past, a cosmic time machine that allows us to study the universe as it was in its earliest days, when stars first ignited, when galaxies began to form, and when the very fabric of the cosmos was being woven into what we see today.